Hello, and welcome to the Risk Matrix training module.
A risk matrix is used to assess the level of risk to an identified hazard, such as falling overboard or cutting oneself using a knife. The level of risk is assessed by 1. Determining the likelihood of the hazard occurring and 2. Assessing the probable consequence as a result of it occurring. The level of risk is typically expressed by 4 colors. Green represents low risk. Blue represents moderate risk. Yellow represents high risk. And red represents extreme risk. In a risk matrix, likelihood is the probability or chance of a hazard occurring, and it increases with the frequency of exposure to the hazard. For example, the more times a deckhand uses a 240-volt grinder on the back deck, the greater the likelihood of electrocution. Likelihood is also influenced by training, knowledge, and experience. For example, an experienced, well-trained deckhand may have less likelihood of falling overboard than a new or green deckhand because he or she knows the movement of the boat and how to operate safely on the deck. The environment can also influence the likelihood of an accident. For example, the likelihood of falling overboard is likely to increase when working on the deck in gale force winds, compared to a day without wind. The likelihood of an accident may be further increased by the person's physical and psychological state. For example, a fatigued deckhand is more likely to fall overboard than a well-rested deckhand. However, the physical and psychological state of the person is not always easy to determine, so consideration needs to be given to the type, amount, and duration of their work when considering the likelihood of an accident. Finally, the likelihood of an accident is influenced by the type and condition of tools and equipment used to complete a task. For example, old rope or chain is more likely to part than new rope or chain. In the risk matrix, the likelihood of an accident occurring ranges from rare to certain. As the boat owner or skipper is responsible for the safety of all on board, and the boat, they are the ones who determine the likelihood ranking for a particular accident. In this way, the matrix is personalized to suit the boat and intended fishing operation. The consequence of a hazard ranges from insignificant to catastrophic, and it is the boat owner or skipper who identifies the consequence of a hazard. The consequence of a hazard should be assessed against a consequence table. This table provides a guide to consistent determination of the consequence of a hazard occurring, which is then applied when using the risk matrix. For example, the consequence of an injury requiring hospital treatment might be considered moderate, while a fatality is a major consequence. That was a lot of information, so let's put it all together in an example to see how it works. Consider this: during refit of a fishing boat, deckhand Robert is required to use a grinder to cut a piece of steel. The grinder he uses has a frayed electrical cord with exposed wiring. With no other safety controls in place, it is likely that Robert may be electrocuted using the grinder and he could die as a result of electrocution. As such, we can calculate the risk level at red 21. Extreme. This is an unacceptable risk, so the skipper takes steps to protect Robert. First, the skipper introduces administrative controls. This includes a safety inspection and tagging of all electrical equipment that is deemed safe to operate. The skipper provides Robert training on inspecting electrical equipment and introduces a policy that Robert must inspect this equipment before it is used. Let's see how this affects the risk level. The administrative controls now reduce the likelihood of electrocution when Robert uses a grinder. It does not eliminate the risk entirely, because if Robert was electrocuted, the consequence could still be fatal. You can see how the likelihood of electrocution was reduced but not the consequence should it occur. Next, the skipper installs RCDs, which immediately switch off electricity should there be a problem with the circuit. The likelihood of electrocution is now reduced to rare, but electrocution and potential consequence is unchanged. Risk rating remains high. The skipper then decides to substitute for a battery-powered grinder. Now the consequence of electrocution from a battery is relatively minor, hence the severity is low. We can see how substitution can reduce the severity or consequence should electrocution occur. The skipper has one final option: to eliminate the hazard by outsourcing the grinding task to a professional. Now the risk to Robert has been eliminated, demonstrating why elimination is the ultimate safety control measure that should be used whenever possible.
Congratulations! We covered a lot of information. Now let's review the material covered.